Welcome back to my home for this episode of MTV Cribs. Later I'll be showing you all the drinks in my fridge. I'm just kidding. This video is actually about non-disjunction. But first I'm going to show you my scar. So I know you've seen enough videos by now that you've noticed this scar. You're a little curious about what happened. So I thought I'd share with you. In early 2023, maybe the end of 2022, my body decided that I should grow a new bone out of nowhere. And so I was growing this long bone and it was just kind of protruding out of the side of my wrist here. And so I went in during spring break and got that cut out. And so now I'm just actively healing, going through mitosis, making a bunch of new cells. Hopefully the scar won't be this wide when it's all said and done, but we'll find out. All right, we're really here to learn about non-disjunction. Non-disjunction happens in meiosis when chromosomes fail to separate properly. So let's kind of recap normal meiosis. And we'll use a pair of chromosomes. Little chromosomes. We actually have 23 pairs. There's really not enough room for all that, so we're just going to represent it with one pair. So if this is a cell, right, this cell is going to undergo meiosis. And so its first step is meiosis 1, right? I'm going to make 2 new cells. Those aren't the same size. Let's even them up a little bit. Whatever, who cares? So our homologous pair here, okay, they're going to separate and go into individual cells. Then we'll undergo meiosis 2. Each of those will make 2 cells. They almost fit. Where those sister chromatids, right, are going to separate and go into separate cells. So we end up with 4 cells that have half as many chromosomes as we started with. We started with 2, we ended with 1, okay, 4 cells. Now, non-disjunction happens when cells, their chromosomes don't separate properly, and it can happen in meiosis 1 or in meiosis 2. So let's look at non-disjunction, just abbreviate it, in meiosis 1 first. We still have a pair. They're going to go through meiosis 1. And they're supposed to separate, but in non-disjunction they don't separate. So both of them end up in one cell and none in the other cell. And so the body's still trying to process this. It's going to undergo meiosis 2. There's nothing to pass down here. These are a pair, so they're going to separate into full chromosomes that are replicated or duplicated. So you can see that they're bigger than this chromosome, still just a chromosome, but that's not viable for any kind of sperm or egg. So every single one of these are useless, and usually in pregnancy, this will result in a miscarriage. Let's look at non-disjunction in meiosis 2. Got a pair of chromosomes here, right? They're going to undergo meiosis 1, and everything goes smoothly, right? Happening like normal. This is what we want to happen. All is good. Meiosis 2 now. In non-disjunction in meiosis 2, we'll have one cell that will behave normally, but the sister chromatids will fail to separate. And so one cell, I'll put it over here, fits a little better. One cell ends up with still this duplicated chromosome and the other cell has nothing in it. So these two are not viable, but these are okay, right? Because they match these originals that were all good. So it would really just depend on which one of these was the egg. If it was one of these, we're good. If it's one of those, we're not good. And in sperm, either one of these are good sperm, either of these are not good sperm. So if the sperm were not carrying the right amount of DNA, then maybe you would just, struggle with pregnancy as well. That's non-disjunction.